brake test on DC shunt motor, or load test on DC shunt motor, or performance characteristics of DC shunt motor. You may observe different panel boards. For all the panel boards, the common thing are LAF of a 3-point starter or LAZ. Sometimes you may have F and sometimes you may have Z. Both are represents the field terminal of a 3-point starter. F and FF for field winding, or Z and ZZ for the field winding. A and AA is for the armature winding. And we are having a DC supply of 220 volts. Coming to the circuit diagram, this is a circuit diagram. You may observe for in the 3-point starter, you may observe LFA or LZA. Both are represents the 3 terminals of a 3-point starter. Aim: to perform a brake test on a given DC shunt motor and obtain the performance characteristics of motor from test observations. Apparatus required: ammeter, type is MC, range is 0 to 2 amperes one number and 0 to 20 amperes of one number. 0 to 2 amperes is for the field current and 0 to 20 amperes is for the armature current. Voltmeter, MC, of rating 0 to 300 volts voltmeter. Rheostat of 370 ohms by 1.7 amperes. Tachometer, digital tachometer of 0 to 9999 rpm. Either you can use a digital tachometer or directly a digital meter, which are as shown. In case of DC shunt motor, the apparatus are voltmeter, type is MC. See, you can observe for MC voltmeter there is in below V there is a dash is there, which indicates the meter is MC. Here plus terminal minus 150 and minus terminal is 150 and 300. Here we are applying a voltage of 220 volts. That's why the scale you need to connect to 300 and observe the scale ranging from 0 to 150. At the same time, it will be used for 0 to 300. And ammeter type is also MC. The range of the ammeter is 0 to 20 amperes. Here positive, plus, and negative maybe 20 or 10. If you observe the scale, it is 0 to 10 and 20. If you observe the scale is uniform scale in case of MC type ammeter. Here you need to use two ammeters. One is 0 to 20 amperes, another one is 0 to 2 amperes. This is 0 to 2 amperes MC meter. Here is a plus is positive, negative will be either 2 or 1. Now here we are using a 0 to 2 amperes ammeter. You need to connect it to 2. Here you can observe the scale, which is uniform scale. Now here this one is a 3-point starter having the terminals L, A and Z. This one is a DPST switch, double pole single throw. We can close the switch by using single throw. At a time 2 switches are closed, and these are the fuses. These are the terminals of armature and field. And this one is a rheostat of rating 370 ohms by 1.7 amperes, where the bottom contact, this one is fixed and this one is also fixed. Now you can vary this one. These are the 3 contacts, 1, 2 and 3. 3 contacts are there. Motor horsepower is 5 HP. Voltage rating is 220 volts. armature current is 20 amperes, wound type is shunt wound, speed is 1500 rpm, and temperature rise is 45 degrees centigrade. 1 HP equals to 735.5 watts. You may have BHP, 1 BHP equals to 746 watts. This is a direct method of testing a DC motor. It is a simple method for measuring motor output and efficiency at different load conditions. A rope is wound on the pulley and its two ends are attached to two spring balances S1 and S2. The tension provided by the balances S1 and S2 are T1 and T2. The tension of the rope can be adjusted with the help of belt. The force acting tangentially on the pulley is equal to the difference between the readings of two spring balances in kg force. The induced voltage EB equals to V minus IARA, where EB is equals to K phi into N, where K is a constant and phi is the flux produced due to the field winding and N is the speed. Therefore, K phi equals to EB by pi, where V is the applied voltage, IA is the armature current, and RA is the armature resistance. The total power input to the motor P in equals to field power plus armature power, which is VF plus IF plus VA IA, is equals to VL IL. Then the torque at the pulley is given by 9.81 into S1 minus S2 into R Newton meters, where R is the radius of the pulley. Motor output power equals to 9.81 into S1 minus S2 into R into 2 pi N by 60, and the efficiency equals to output power by input power into 100. A DC shunt motor rotates due to the torque developed by the armature when the armature and the field terminals are connected to the DC supply. The direction of the rotation can be explained with the help of Fleming's left-hand rule. A counter EMF or back EMF is induced in the armature conductors while the armature motor is rotating in the magnetic field. The direction of the induced EMF can be explained with the help of Fleming's right-hand rule. The direction of induced EMF is such that it opposes the applied voltage. Thus, this induced EMF is also known as back EMF. The back EMF EB. The equation for the motor is given by V equals to EB plus IARA, where EB equals to pi Z and P by 60A. Therefore, IA equals to V minus EB by RA. The value of EB is 0 while starting the motor. Hence, the voltage across the armature has to be increased gradually. The power developed by the motor is EB into IA equals to T into W, torque multiplied by angular speed, where omega equals to 2 pi N by 60. The angular velocity of the pulley in radians per second. In a DC motor, torque is directly proportional to pi into IA, where phi is nothing but flux produced by the shunt field pole and IA is called armature current. The torque developed in the motor is opposite with the torque due to the friction and windage, eddy currents and hysteresis and mechanical load connected to the procedure. Connect the circuit as per the circuit diagram. Now, based on the panel board and if the equipments are digital equipments, you can give the connections like this. Circuit connections from supply positive connected to DPST switch, first terminal, DPST switch, first terminal, first switch, second terminal is connected to fuse, first terminal, first fuse, second terminal is connected to ammeter positive and voltmeter positive. Coming to supply negative is connected to DPST switch, second switch first terminal, DPST switch second terminal is connected to fuse first terminal, fuse second terminal is connected to, this is a fuse second terminal. From here you need to give the connections. For our understanding purpose, these all connections are connected internally. From supply positive you need to connect two wires. One wire is to voltmeter positive, another wire is to ammeter positive. 0 to 20 amperes ammeter positive. From supply positive connect two wires. One wire is to voltmeter, another wire is to voltmeter positive, another wire is to ammeter positive. Zero to 20 amperes ammeter negative is connected to 3-point starter L. Ammeter negative terminal 0 to 20 amperes ammeter negative terminal connected to L of the 3-point starter. The 3-point starter A is connected to DC shunt motor armature winding, which is A. A of the 3-point starter is connected to armature winding of the DC shunt motor. From 3-point starter Z, we need to connect one wire which is connected to 0 to 2 amperes ammeter positive terminal. From F field, connect one wire which is connected to 0 to 2 amperes ammeter positive. 0 to 2 amperes negative terminal, 0 to 2 amperes ammeter negative terminal is connected to rheostat ammeter 0 to 2 amperes ammeter negative is connected to rheostat fixed terminal. Rheostat variable terminal is connected to Z. From the rheostat variable terminal connected to Z of the field winding. Supply negative, we need to connect 3 wires. One wire is to voltmeter negative terminal, another wire is to ZZ, and the third wire is to AA. From supply needed terminal, connect 3 wires. One wire is to voltmeter needed terminal, second wire is to ZZ, and third wire is to AA. Now the rheostat must be in minimum position. From supply positive, we need to give 2 wires. One wire is to voltmeter positive, another wire is to ammeter 0 to 20 amperes, ammeter positive. From supply positive, connect 2 wires. One wire is to voltmeter positive, one more wire is to ammeter positive, ammeter 0 to 20 amperes positive. 0 to 20 amperes ammeter negative is connected to 3-point starter L. Ammeter negative is 20 amperes connected to L, 3-point starter L. 3-point starter A is connected to the armature winding of the DC shunt motor. Three-point starter A connected to armature, motor armature. The 3-point starter F is connected to 0 to 2 amperes ammeter positive terminal. 3-point starter Z connected to ammeter positive 0 to 2 amperes ammeter positive, 0 to 2 amperes ammeter negative is connected to rheostat. Negative is connected to rheostat first terminal. Rheostat fixed terminal is connected to F. This F is called field winding terminal. From rheostat second terminal, you need to connect it to Z. Supply need terminal, we need to give 3 wires. One wire is to voltmeter need terminal, the second wire is to AA of the armature winding, and the third wire is to FF. Supply needed terminal, we need to connect 3 wires. One wire is to voltmeter 300 volts, one wire is to armature AA, one more wire is to ZZ. Keep the field resisted in minimum position, minimum resistance value. Check the belt on the pulley is free. Switch on the power supply by closing DPST switch and start the motor using 3-point starter. By wearing the field resistor, run the motor at rated speed. Now note down the values of voltmeter, ammeter, tachometer, spring balances S1 and S2 at no load. Gradually increase the load in the motor in steps by tightening the belt on the drum till ammeter reads the rated current of the motor. Take the readings of voltmeter, ammeter, tachometer and spring balances readings in each step. Cool the pulley throughout the loading period by pouring water. After completing the experiment, put the field resistor to its original position and switch off the power supply by opening the DPST switch. Tabulate the observations. Tabular column, serial number, voltage VL, which is in volts, IL is in current in amperes, IF is the field current, spring balances S1 is kg and S2 is in kg, speed is in rpm, torque is units or newton meter, input power is multiplication of VL and IL, and output power is torque multiplied by angular speed. Therefore efficiency equals to output power by input power. Before switching on, there must be no load. Before switching on, there must be no load or the belt must be loose. Now close the MCP and start the motor using 3-point starter. Now place the speed to 1500 rpm by varying the restart. You can observe the speed is 1477, 1486, and we are varying the restart. Now we will keep the speed of the shunt motor is 1500 rpm and note down the readings of voltmeter, ammeter, field current, VL, IL, field current and speed, and S1, S2. Now increase the load step by step in terms of 2 amperes, 3 amperes, 4 amperes, and corresponding note down the ratings of voltmeter, ammeter, armature current, field current, speed, and you can reach up to rate current. The rate current is 20 amperes. Here we are applied up to 11 amperes. ఇంకా పెంచు వెళ్ళి పెంచు 4 వరకు పెట్టు పెట్టు రోడ్ పెట్టి పెద్దది If the equipments are analog equipments, you can give the connections like this. Before starting, the brake drum must be loose and there is no weights. S1 must be 0 and S2 must be 0. Close the TPST switch. Once you can observe the voltmeter reading, once you are closing the switch, voltage will be appear. Current కలిపి చూపించు. Start the motor using keyboard starter. Measure the speed using tachometer. The speed is 1370 rpm. Now by varying restart, you can adjust the speed up to 1500 rpm. can adjust the speed up to 1500 RPM. Take the readings of voltmeter reading, ammeter reading, field current reading, and gradually increase the load and apply the load and take the readings of voltmeter, ammeter, and field current and speed. By tabulating the values from the above experiment, we can by substituting the values, you can find out the values of input power, output power, and efficiency. Coming to the calculations, torque formula is 9.81 into S1 minus S2 into R. Output power equals to 2.60. Input power is VL into IL, and the efficiency is output power by input power into 100. Precautions: avoid loose connections. Don't touch the circuit connections while power is on. Take the meter readings without parallax error. Pull the pulley while experiment is performed. While measuring the radius of the pulley, effective radius must be considered. Model graph. This is a model graph for torque versus speed. If you plot the graph, torque is on x-axis and speed is on y-axis. This is the graph for the above values. Similarly, you can draw the performance characteristics of a DC shunt motor, where output power is in watts, which is on x-axis, and torque, efficiency, load current, and speed, these all are in y-axis. Now this is the model graph for the performance characteristics. By plotting the graph, this is a graph. By substituting the values, you can plot. This is a graph of the performance characteristics of DC shunt motor. Result: thus, the brake test on DC shunt motor is performed. Efficiency has been calculated at different loads, and performance characteristics are drawn. Conclusion: as load increases, the efficiency of the motor increases up to a certain point. Beyond the optimal load, efficiency may drop due to increased losses. As load increases via the brake, the torque increases. Thank you for watching. Please share and subscribe if you like.